students, we have studied that a covalent bond is formed by the overlapping of two half-filled atomic orbitals. Depending on the type of overlapping, the covalent bond may be divided into two types. There are two types of covalent bond. Sigma bond or sigma covalent bond and pi covalent bond. Okay, yes. Then what is meant by sigma bond? How sigma bond is formed? Okay, please consider the example. The formation of a hydrogen molecule H2. Okay, we know hydrogen molecule is formed by the combination of two hydrogen atoms. Okay, H plus H gives H2 and the atomic number of hydrogen is 1. Its electronic configuration is 1s1. Yes. Then we know the hydrogen atom has half-filled 1s orbital. Okay, s orbital. Its shape is spherical. Yes. Then here the half-filled s orbital of one hydrogen atom overlaps with these two electron clouds. These two atomic orbitals, half-filled s orbital, okay, overlap along the internuclear axis. What is meant by internuclear axis? Internuclear axis is nothing but the line joining the center of the nuclei of the two atoms. Okay, the line joining the center of the nuclei of two atoms, like this. The line, yes, passes through the nuclei of these two bonded atoms with these two hydrogen atoms. Okay, then this axis is called the internuclear axis. Internuclear axis means what? The line passes through the nuclei of the bonded atoms in a molecule. If the overlapping takes place like this along the internuclear axis, the bond formed is called the sigma bond. Okay, then what is meant by sigma bond? Okay, sigma bond is formed when two half-filled atomic orbitals belonging to the bonding atoms overlap along the internuclear axis. This type of covalent bond is called sigma covalent bond. So here, yes, in case of H2, the two half-filled atomic orbitals of two half-filled s orbital of two hydrogen atoms overlap. Yes, these two electron clouds along the internuclear axis, and here H sigma bond, H sigma covalent bond is formed. Okay, thus the bond formed as a result of the axial overlap, or end to end, these two ends, okay, undergo overlapping, end to end overlap or head-on overlap is known as sigma bond. Then the sigma bond or this axial overlap involving the orbitals is of three types. Okay, then that means the sigma bond is formed by, so the axial overlap takes place by number one, SS overlapping. This example, the SS overlapping, number one. Okay, Number 2, SP overlapping, and number 3, PP overlapping. Okay, then SS overlapping. SS overlapping. Number 1, SS overlapping. SS overlapping. Okay. Okay. This SS overlapping occurs when two half-filled s orbitals overlap along internuclear axis. Okay. Then the second one is SP overlapping. Then SP overlapping occurs between the half-filled s orbital of one atom and half-filled p orbital of other atom. Okay. Half-filled s orbital of one atom overlap with half-filled p orbital of another atom along the internuclear axis. Okay. Then here forms a sigma covalent bond. Okay. SP overlapping. This SP overlapping takes place along the internuclear axis. This overlapping is also called ND2. These two ends undergo overlapping. Hence, it is called end-to end overlapping or head-on overlapping. Then, the example for SP overlapping. Please listen. The formation of hydrogen fluoride HF molecule. Okay, already we know the hydrogen atom has half-filled s orbital. Okay. Then fluorine, its atomic number is 9. Okay, its electronic configuration we know 1s2, 2s2, okay, 2px2, 2py2, 2pz1 according to Hund's rule. Okay, we can fill the electrons in 2p orbitals. Then fluorine atom has half-filled 2pz orbital. Yes, then here the half-filled s orbital of hydrogen and half-filled pz orbital of fluorine overlaps, okay, along the internuclear axis, and here forms a HF sigma bond. HF sigma bond. Next type overlapping is PP overlapping. PP overlapping occurs when two half-filled p orbitals overlap along the internuclear axis. Here, the half-filled p orbital of one atom overlaps with the half-filled p orbital of another atom along the internuclear axis. Okay, and forms a sigma bond. Here, PP overlapping takes place. The example is formation of fluorine molecule. Already we learned fluorine atom has half-filled 2pz orbital. Here the half-filled 2pz orbital of one fluorine atom overlaps with one half-filled pz orbital of another fluorine atom. Yes, along the internuclear axis and forms FF sigma bond. FF sigma bond. Okay, next type of covalent bond is pi bond. Please listen. Pi bond is formed by the lateral or sidewise overlapping of p orbitals. Lateral or sidewise overlapping of p orbitals. Here the condition for the formation of pi bond is that the p orbitals must lie perpendicular to the internuclear axis. Okay, here the two p orbitals lie in a direction perpendicular, or we can say right angles to the internuclear axis. Nucleus of one atom, nucleus of another atom. This is the internuclear axis. Then these two p orbitals lie perpendicular to the internuclear axis. Okay, when the p orbitals involved in overlapping lie perpendicular to the internuclear axis, sideways or lateral overlapping takes place like this. Please listen. Sidewise overlapping. Okay, like this. Sidewise overlapping. Sidewise. Okay, here the p orbital of one atom, this one, p orbital of another atom. These two p orbitals lie perpendicular to the internuclear axis. Then, yes, these two lobes overlaps each other, and the lobes lying above the plane or above the internuclear axis overlap each other, overlap sideways, and the two lobes, the two electron clouds or two lobes lie below the internuclear axis also, yes, overlap by sidewise. Okay, then here pi bond is formed. Okay, here please listen. The pi bond consists of two electron clouds. Okay, above the internuclear axis. Okay, or above the internuclear axis and below the internuclear axis, or we can say the pi bond consists of two electron clouds above and below the plane of the two atoms which are involved in bond formation. Okay, like this. This is the internuclear axis. Okay. Then here these two lobes lie above the internuclear axis. Okay. Then yes, by the overlapping of these two lobes, one electron cloud is formed. This electron cloud lies above the internuclear axis, and the another electron cloud lies below the internuclear axis, or we can say half of the pi bond is formed above the internuclear axis and half of the pi bond is formed below the internuclear axis. That means what? One pi bond is formed. Then what is meant by pi bond? Pi bond is formed by the lateral or sidewise overlapping of p orbitals. Okay? Okay, here only p orbitals involved in pi bond formation. Then the strength of a bond depends upon the extent of overlapping. The extent of overlapping is large. Sigma bond formed is stronger. Okay, sigma bond is a strong bond, but in the formation of a pi bond, sideways overlapping takes place only to small extent, and it is a weak bond. Okay, pi bond is a weak bond, sigma bond is strong bond. Yes, then let us discuss the main differences between sigma bond and pi bond. First difference, sigma bond is formed by the overlapping of half-filled atomic orbitals around the internuclear axis. But the pi bond is formed by the sidewise or lateral overlapping of p orbitals. Then in the case of sigma bond, extent of overlapping is large. Okay, and hence the sigma bond is stronger, but extent of overlapping is small, and hence pi bond is a weak bond. Yes, and the third difference The bond can be formed even in the absence of pi bond. Okay? But the bond, in the case of pi bond, the bond cannot be formed in the absence of sigma bond. That means sigma bond can be formed even in the absence of pi bond, but the pi bond cannot be formed in the absence of sigma bond. Okay. Okay, please listen. The single bond consists of only one sigma bond. Single bond means one sigma bond. But a double bond consists of one sigma bond and one pi bond. But triple bond consists of one sigma bond and two pi bonds. Okay, the sigma bond can be present alone. Okay, but pi bond is formed only in the presence of sigma bond. Okay, pi bond is formed only in the presence of sigma bond. Every bond consists of, each bond consists of one sigma bond, then the rest of the bonds are pi bonds. That means what? Every bond consists of one sigma bond, then the remaining bonds are pi bond. That means single bond consists of one sigma bond, zero pi bond. Double bond consists of one sigma bond, one pi bond. Then triple bond consists of one sigma bond, two pi bonds. And the last difference, free rotation of the atoms around sigma bond is possible. For example, H sigma bond. Here the free rotation of hydrogen atoms around this HH sigma bond is possible, but free rotation of atoms around pi bond is not possible. Okay, students, in my next video I will discuss next important topic, very important topic from this chapter, that is hybridization. Okay, goodbye, study well.